Hello everyone, and welcome to part 2 of the curve properties series. So in this episode we're going to be looking at a question that we're going to walk through, and it's going to ask us about some of the concepts we learned in the first video. So if you haven't seen the first video of the curve properties series, really recommend that you watch that to be able to get a conceptual understanding of what's going on. Okay. So first off, let's rewrite out our function that we're going to work with, and let me talk you through the problem. So the nature of the stationary points is something we need to work out from this cubic polynomial here. So it doesn't tell us whether we're going to be encountering maxima or minima, and it essentially tells us that we have to be able to work out what they are and state what they are. Next, it gives us a polynomial, as I said, and I've already rewrote that out. And it gives us an interval to look at it for. So we're going to be looking at it where x is going to be greater than -4, but it's going to be less than or equal to 4. And then lastly, it wants us to find the minimum coordinate point within the series. And that may not necessarily be a turning point minima, as I will show you in this video. So first off, we want to be able to find the derivative, the dy over dx, because of course, when the dy over dx, the derivative is 0, then the slope of the tangent, or the gradient at that given point, is going to be a horizontal line, is going to be equal to 0, meaning we have a stationary point. So now, let's differentiate, shall we? And it helps if you rewrite out the function correctly. So dy over dx. And what we do is we bring that exponent to 3 and we multiply it by the coefficient there. So it's 3 times 1, it's going to make 3, x, and then we subtract 1 from the exponent, so we get 3x squared. Then we multiply the exponent by our coefficient, so we have 2 times 2, which makes 4, and then we subtract 1 from exponent. 2 take 1 is going to be equal to 1, so we just have plus 4x. And then the derivative of a constant is 0, and I've went through that several times before in previous videos talking about horizontal lines. So we're done. We've differentiated our function. We then set it to 0 because we want to find these stationary points. And what we need to do is we need to be able to factorize. And you can do this by hand or you can use technology. For the purpose of keeping this video short and interesting, I'm going to use technology, and I'm going to explain how to factorize using a TI-84 Plus graphics calculator. So you want to press the on button first, because that always helps. And then you want to press apps, and the apps key is located below your X value key. Then you want to scroll down using the arrow key and go to Poly SMLT2. This is Poly Simulator 2. And press enter. It should be the 8th one on your list. And then you just need to press any key to enter the app. And then you need to press 1 for Poly Route Finder. Where it says order at the top, scroll across to 2 if it isn't on 2 already, and then press the F5 button or the graph button to go to the next screen. Then when it says A2, enter 3 because this is the coefficient of our x squared term. Then where it says A1, enter 4, because that is the coefficient of our x to the power of 1 term. And then where it says A0, enter nothing, because we have no constant on the end. Then press the graph button again, or solve, and we should get 2 answers. So these x values are the stationary points. And I've simplified it a bit because negative 1.333 is going to be, of course, a negative a third, negative 4 over 3 in improper fractions. Negative 1 and a third becomes negative 4 over 3. Hopefully you can see how I did that. And now what we do is we draw a sign diagram, and we want to be able to fill in the gaps. So what would our sign diagram look like? Well, we start off with a number line, And I'm going to switch to red because I reckon it's going to look nice. And we have our stationary points, -4 on 3 and 0, something simple like that. Of course, that isn't necessarily really good to scale. It would look something similar to that. And then you'd have 4 out here somewhere, -4 out there, and then 4 out here because that's the interval we're looking at. But we want to be able to fill in these gaps for our turning points on the cubic. So now, well, what do we do to be able to find out what's happening to the slope here? We need to look at the derivative. So we simply substitute in a value less than -4/3 and work out whether it's a negative or positive derivative, which will make us realize whether it's an increasing or decreasing slope. So we take our derivative, our dy over dx, and let's find the f prime of -2. -2 is less than -4/3. So f prime of -2, and we simply substitute in -2 into our equation where applicable, and we're left with 3 lots of -2 squared. -2 times -2 makes +4. +4 times 3 is 12, and then 4 times by -2 is -8. So it's 12 take 8, which equals 4, and therefore our slope is obviously going to be increasing because the derivative is positive. And when the dy over dx is greater than 0, then of course positive slope, so we can add that into our sign diagram, and we can make it actually look like a plus for increasing. So now we want to be able to look in this region here. Is it a horizontal inflection? Is it a maxima? Is it a minima? That's what we want to be able to work out, because it asks us what is the nature of the stationary point. What type of stationary point are they? So let's pick a value between -1 1/3 and 0. I think we could go for -1 in there, because that would be nice and easy to do the arithmetic for. So the f prime, again, we use the derivative to work out what's happening to the slope, derivative slope. And then we have 3 lots of -1 squared, and sorry I'm squishing this a bit, plus 4 lots of -1. Now -1 squared makes +1, right? So we have 3 times +1, which is going to make 3. And then what we have is we have -1 and 4, and -1 and 4, -1 times 4 is going to make -4. So it's 3 take 4, and that's going to make -1. So therefore we have a decreasing slope because we have a negative derivative. And lastly, we want to find out what happens to the slope when x is greater than 0. So the f of 0, we're going to make it greater than 0, we're going to make it 1, because at 0 the derivative is obviously going to be 0. So the f of 1 equals, and again we simply substitute that into the derivative formula. This one here, in case you're not sure where I'm getting it from. Now, 3 times by +1, because 1 times 1 is 1, so 3 times the +1 is 3, and then 4 lots of 1 makes +4, so we have a positive derivative. And because we have a positive derivative, it means that our slope is increasing. Okay, cool. So what does this mean in terms of our stationary points? Well, x is going to be increasing, or should I say, the function is going to be increasing when x is less than -1/2. So it's going to be increasing, and then we're going to have a stationary point, and then it's going to start decreasing. And we don't know how much it really does decrease unless we graph it, or you can sort of conceptualize this in your head maybe, one of the two. And then we have another stationary point, and then it starts increasing. So what does this tell us about the stationary points on this function? Well, this is going to be a maximum, isn't it? It may not be the global maxima of our function, but it is going to be a maximum, because it turns from an increasing slope to a decreasing slope. And this one's going to be a minimum, isn't it? And there we go. We've worked out the nature of our roots. So now what we do next is we work out the minimum value. Now, this could be the minimum value, this minima here. But because it is also increasing here, it might be something on that slope there within the interval. Remember, we're just looking between x is negative 4 and x is positive 4. We're not looking all the way down here where it's negative infinity. We're just looking between x is negative 4 and x is 4. So, we need to work out if the f prime of negative 4 is less than or greater than our f prime of 0. Or should I say our f of 0? Sorry, our f of 4, negative 4, and our f of 0. We're not looking at the derivative anymore, but we're actually looking at the function in general. Sorry to confuse you a bit there. But again, that's what we're sort of doing. We're just working out, is the minima the most minimum value in that interval, or is this part on the increasing region the most minimum? So this is where we actually don't take the f prime. All these are f prime, even though I forgot to put the prime in there, because we're looking at the slope. Here is where we look at the function and say, okay, where is the minimum coordinate point on the function? And for this, I'm going to go to the other side of the board, and hopefully I don't produce too much shadow. I'll try not to. I know I will initially. Yep, there we go. Okay, so what we do now is we have our f of 0 and our f of negative 4. And I think the tripod just sprung a little bit there. Hopefully it didn't disrupt anything. Nope. Okay, so now what we do is we're just finding out again what happens on our function. So the f of 0, we take our original function, and it's 0 to the power of 3 plus 2 lots of 0 squared plus 7. So it's going to be equal to 7, the coordinate point 0, 7 there. You can see how I got that because that's 0 plus 0 plus 7, 7. Now negative 4 is a little bit trickier. Negative 4 to the power of 3 plus 2 lots of negative 4 squared plus 7 equals... Now negative 4 times negative 4 is positive 16. Positive 16 times by negative 4 is going to make negative 64. So that's going to be negative 64 there. And now negative 4 times by negative 4 for negative 4 squared there is going to be equal to positive 16. And positive 16 times by 2 is going to make positive 32. So overall that's still negative 16. And now we add 7. Negative 16 plus 7 is negative 9. So we have the coordinate point, negative 4, negative 9. And that is going to be lower on the graph than 0, 7, isn't it? So this means the lowest, or most minimum value on our function, on our original function, within the interval, that's the interval there, is negative 4, negative 9. Because it can be less than or equal to negative 4. And there we go. We've worked out everything that our question asked us. Hopefully you were able to follow okay. Hopefully you sort of got the idea between what you use the derivative for and what you don't. But that's a look at curve properties part 2. Another video coming out soon. And we'll go through some more cool questions. But until then, any questions, leave them in the comments box. Thank you.